Let's take a look at the inverse property of addition and multiplication. So the inverse property of addition is that a plus negative a equals 0. Okay, it's called the inverse property because we're adding, but we have positive a. So the inverse or the opposite of positive a is negative a. So a plus negative a is 0. So, for example, 3 plus negative 3 equals 0. And we'll see 3 plus negative 3, 0 equals 0. It's the inverse property of addition. Okay, let's look at the inverse property of multiplication. Okay, so we have the variable a, and we multiply it by 1 over a, we get 1. So it's multiplication. The inverse multiplication is division. So just a side note, I'll write it up here. A divided by a is the same as a times 1 over a. So it's kind of like saying a divided by a is 1. So the inverse of multiplication is division. And quick example, 3 times 1 over 3 equals 1. If you multiply fractions, we have 3 over 1 times 1 over 3. 3 over 3 is 1, and 1 is 1. It's the inverse property of multiplication. These two properties come in handy when we're solving algebraic equations. Let me give you an example of that, of how we're going to actually use these. So these are the properties, but let's put them into real use. So let's say we have x plus 5 equals 13. In algebra, we want to isolate this variable x. Okay, but there's a plus 5 here. So how do we get rid of this plus 5? We have to do inverse operations. So we're adding 5. So to get rid of it, we should, according to this, add a negative 5. Or simply subtract the 5. But if we subtract 5 over here, this side of the equation is going to equal that side. Because this combination here, this x plus 5 is supposed to be 13. So we have 13 is 13. If we subtract 5, it's not going to be the same number anymore. So to keep it the same, we have to subtract 5 from that side as well. So 5 minus 5 is 0. That cancels out. So we have x is 13 minus 5, which is 8. So we're able to solve for x using inverse operations. X is 8. Okay, let's try a similar problem over here. Say we have 5 times x equals 20. Again, we want to get x by itself, but there's a 5 here. They're being multiplied. So we have to get rid of this 5 somehow to get x isolated. So because it's multiplication, the inverse would be to multiply it by 1 over a. And like I showed, multiplying by 1 over a is the same as dividing by a. So if it's 5 times x, to get rid of the 5, we should divide by 5. And again, we can't just divide by 5 over here. We have to do it on the other side so that this side still equals this side. 5 divided by 5 is 1, just like this shows. So now we just have 1x, or simply x. 20 divided by 5 is 4. So we find out that x equals 4 by using inverse operations.